नमस्कार बच्चों, मेरा नाम धन्या और हम लोग आज ग्रेड 11 केमिस्ट्री का ऑर्गेनिक केमिस्ट्री स्टार्ट करने वाले हैं। और टुडे वी आर गोइंग टू लर्न अबाउट द tetravalency and catenation nature of carbon, and also we will be discussing the IUPAC rules for naming organic compounds, and today we will be focusing on alkanes. Okay, so this is a big lesson. So today we will be focusing on alkanes. Okay, now students, you all know that carbon has a configuration of 2,4. Now there are 4 electrons in the outermost shell. Okay, so it has to satisfy the 4 valencies. So it quickly forms 4 bonds with other atom. It also forms bonds with other carbon atoms. Okay. And because it has to satisfy the 4 valencies, it is called as tetravalency. So this is 1, 2, 3, 4. It is called tetravalency because it has to satisfy 4 valency. Okay. And it also shows catenation behavior. Catenation means that, so this is tetravalency nature. Tetravalency, it has to satisfy 4 valency. So many of you will be knowing this. Okay, now we are discussing one important nature of carbon, catenation. Now, catenation means the ability to form stable bonds with atoms of the same elements. For example, here, carbon is forming a long chain. Okay, it is bonding with other carbon atom, and these bonds are very strong. So this is the long chain. Okay, and these carbon-carbon bonds are very strong. Okay, it can also form double bonds like this. Carbon can also form double bonds. Yes, it can also form triple bonds. Okay, so catenation is the property to form long chain with the same atoms. Okay, for example, carbon displays this property. It forms a long carbon chain by bonding with other carbon atom, and these bonds are very, very strong and also very stable too. Okay, so this is the property of catenation. Sometimes it may form also branched chains. For example, you can see here, branchings are there. Okay, so I'm filling the hydrogen atoms. So as I am writing, I'll tell you how I am filling the hydrogen atoms, the requirement of the hydrogen atom. So for example, 1, 2, 3, 4, 5, and suppose the branching is here. Okay, so this is the catenation property of carbon, where it is forming long chain. Okay, and here you can see a branching also. Okay, so I'm filling the hydrogen atom according to the tetravalency nature. Okay, for example, here there is one bond, means one valency is satisfied. See, 3 more is needed. So 3 plus 1, 4. Here 2 valencies are satisfied. It needs 2 more. So accordingly, I'm filling the hydrogen atom. So 1, 2, 3, I need 1 more hydrogen here. Here 2 valencies are satisfied. So I need 1 more. Here 1 valency is satisfied. So it needs 3 more. So 3 plus 1, 4. So here also they are forming branched chain structure. Okay, similarly, it can also form cyclic structures like this. This is cyclohexane. Okay, and each of these are carbon atoms. I'm sure you will be knowing this. Each of these is carbon atom. So this is the catenation property. Ability to form a stable bond with atoms of the same element. Here carbon is forming strong bonds with other carbon atoms, forming a long chain, branched chain, or even cyclic structures. So these two are important properties of carbon. Okay, tetravalency property and the catenation. Okay, now coming to the next topic. Coming to our next topic, which is called as basic rules for the nomenclature of alkanes. So today we will be discussing about alkanes. In the coming videos, we will be discussing about alkenes, alkynes, etc. Okay, so today we will focus on alkenes. Now, the nomenclature of different organic substances is follows a rule which is called as IUPAC. And the full form of IUPAC is International Union of Pure and Applied Chemistry. Okay, so in order to maintain uniformity, everyone follows this rule. International Union of Pure and Applied Chemistry, they have set up a rule, some rules according to which the naming is done. Okay. Now, according to this IUPAC, we have first, please listen to this carefully. Okay. First, we write the prefix. So whenever an organic substance is named, first the prefix is written. So first lesson, we will be practicing prefix. Okay. In prefix, there is 20 means secondary, 10 means primary. Okay. So first we talk about secondary and then primary. Okay. So if secondary prefix are there, for example, branches. Like, for example, substituents. Branches or substituents. Okay. And for this, we write the position also, which is very, very important. Okay. And then we have the primary. Primary means which is used in cyclo, bicyclo, etc. So in IUPAC naming, first we mention the prefix. Prefix can be of two types, secondary. Secondary means branches or substituents, etc. Okay. And in this, we mention the position also. So substituents can be like, for example, methyl, fluoro, nitro, all those are. I'll be writing that first. First, we will understand the order, in what order it is written, and then we will talk about different substituents, etc. Okay, so first prefix is written. After that, we write the word root. Word root means number of carbon atom in the main chain. Okay. Then the word root is written, and next we write down the suffix. Okay. So in suffix also, first we write down the primary suffix. Primary suffix means whether it is what type of carbon-carbon bond it is. Type of carbon-carbon bond in the word root. Okay, in the word root. So if it is a single bond, we write "ane." Whether it is a double bond, we write "ene." If it's a triple bond, we write "ine," etc. So here, what type of bond means whether it's a single bond, double bond, or a triple bond, we have to mention. Okay, next is secondary group, secondary suffix. Next, we write down the secondary suffix, which mentions about the functional group. Functional group. Functional group can be alcohol, okay, can be aldehyde, ketone. So for functional group, I'll be making another separate video. Today, we will be concentrating more on the alkane group, okay? Okay, so this is the order. Okay, so this is how we write down, how we go about with the name. Okay, so I hope you have noted down. So what is the order in which we write down the name? First is the secondary substituent. Okay, then we write down the primary. So this is all prefix, right? So secondary prefix first. In prefix, we write down the secondary substituent and then the primary, which can be cyclo or bicyclo, etc. Okay, then we write down what? The word root. Word root. Word root. In word root, what do we write down? The number of carbon atom. Where? In the main chain. Okay, after that, we move on to suffix. So this is the order. If we memorize this order, it will be fine. Okay, in in suffix, we write down first the primary one, primary suffix. Primary suffix, what do we mention? Type of carbon-carbon bond, whether it is single bond, double bond, or triple bond. After that, the secondary suffix. In secondary suffix, what do we mention? The functional group, which can be aldehyde, which can be ketone, which can be acid, which can be alcohol. Many functional groups are there. We will be discussing this. So this is the order. Okay, so this I will keep it. Okay, so that it's easy for us to refer back. So this is also previous. I hope this order you're clear with. Okay, now coming to the substituents, some of the substituents. Substituents, where do we write? We write it beginning, prefix, okay? As a prefix, we write down, okay? So some of the substituents are, and for them, the position is very important. We need to mention the position. So substituents are called as branches also. They are not in the main chain. Okay. And substituents can be nitro group. This is nitro. Then I have X, wherever you find X, that means it can be halogen. Okay, if they have given as a generalized form, they can mention X, which is halogen, can be any halogen. Halogen can be F. If it is F, we call it fluoro. Sorry. If it is Cl, chloro. If it is Br, we call it bromo. If I call iodo. Then if it is NO, we call it nitroso. If it is N3, azo. If it is R, we generally call it alkyl. Alkyl can be, if it is CH3, it is methyl. So methane is CH4. So removing one hydrogen is called methyl. Okay. Then ethyl, C2H5 is ethyl. Okay. So C2H6 is ethane. When you remove one hydrogen, it is ethyl. Okay. Then I have C3H7. It is propyl. Now, here, if I have propyl means there are 3 carbon atoms. So suppose if I mention like this, CH3, CH2, CH3. Okay. So here it should be CH2 because it has to satisfy the tetravalency. Okay. So this is a normal propyl because it is a straight chain. Okay. In case I have CH3, C, H, CH3. Okay, suppose here you can see this is not straight chain. It is branched. We call it as isopropyl. Okay. Similarly, if I have so these are normal isopropyl, normal propyl, etc. We will be discussing in another video just to get a small idea. Similarly, if I have this is 4 carbon atom. So that means this is butyl group. Okay, and this is a straight chain. So this is called as normal butyl. If it is branched, it is called as isobutyl. Okay, so all those will be discussing, I think. Now, coming to the few more subsequents. If I mention OR, it's a general version. This is called as alkoxy group. Alkoxy group. Okay, so alkoxy group I mentioned in this row. So OR is called as alkoxy group. And R stands for any of the alkyl group. For example, if I have OCH3, this R stands for any of the methyl, ethyl, or any group like that. So methoxy. Okay. Then if instead of CH3, I have COC2H5, it is called ethoxy. And sometimes C2H5 is mentioned as short form like this in some books. ET stands for ethyl. Okay. Then OPH, where pH stands for what? Phenoxy or phenyl group. Okay. So here pH stands for, this whole thing is called as phenoxy group. Okay. And this pH stands for phenyl group. For example, what is phenyl group? Like for example, in methane, when I remove one hydrogen, it is called as methyl group, right? Similarly, for benzene, this is C6H6 is benzene. If I remove one hydrogen, it is called as phenyl group. I hope I'm clear here. So one hydrogen is removed. Okay, so I hope you have noted down the different substituents. So these are mentioned first with their position. Okay, so these are some important substituents. Okay, so I'm rubbing this. I hope you have taken a screenshot. Okay. The next prefix is cyclo. We will mention in the next video, but then the next one, what we are going to do is word root. Okay. Once you get an idea how to name it, then everything will be good. Okay. Now coming to word root. Next one is word root. That means number of carbon atom in the main chain. Okay. So we usually take the longest chain. We usually take the longest chain. Okay. So if there is one carbon atom, we call it meth. Okay, for methane. Okay. If there are two carbon atoms, so these terms you should know. Ethane. Okay, or if it is a double bond, ethene. Okay, so accordingly, so this is just the word that we use for two carbon eth. If it's 3 carbon, we use prop. If it is 4 carbon, bute. 5 carbon, pent. 6 carbon, hex. 7 carbon, hept. 8 carbon, oct. 9 carbon, non. 10 carbon, dec. Okay. 11 carbon, undec. Okay. So 12 carbon, dodec. So you have to learn until this. Okay. After this, it won't be coming. Okay. Probably. So here only. So these are the terms that we use if it is for 1 carbon, 2 carbon. Okay. All these. I hope you have noted down. Right. Now, coming to the next one is suffix. Primary suffix. Okay. Primary suffix means carbon-carbon bond. So primary suffix, what you have to mention, the type of carbon-carbon bonds, right? So carbon-carbon bonds were in the main chain. If it is a single bond, we mention in. If it's a double bond, we write in. If it's a triple bond, we write it ein. Okay. And the last thing to mention here is the secondary suffix, which tells about the functional group. So secondary suffix tells us about the functional group. It can be aldehyde, it can be acid, it can be ketone. Okay. So many functional groups are there that we will put a separate video for that. I hope you got an idea what are the things to be done in the substituents in the prefix. I hope you got an idea about the prefix, about the word root, about the suffix. Okay. Now, coming to the rules or nomenclature. So the rules for nomenclature. First rule is that you have to select the longest carbon-carbon chain. Okay, selected, and it's not necessary that it should be straight. Okay, it can be branched also. So, and the chain need not be straight. For example, if I have 1, 3, 4, okay, so I have to select the longest chain here. So we have to check. So 1, 2, 3, 4, 5, 6, 7. Okay, so I can number like this, or I can also number it like this: 1, 2, 3, 4, 5, 6, 7, 8. Which of them is giving me longest chain? 7 or 8? It is obviously 8. So we will not use this numbering. In fact, we will use this numbering where there are 8 carbon atoms we are getting. So this is the long chain. So you have to check first which is giving you more longer chain. Okay, so you have to select that. Okay, so this is one example. Or suppose I give another example where 1, okay, and right. So suppose I am numbering it 1, 2, 3, 4, 5. Yes, I can also number it 1, 2, 3, 4, 5. Both of them are giving me 5, a chain of 5 carbon atoms. But I would like to select So this is another preference we had done, right? Now, if suppose both of them have the same number of carbon atom in the chain, which one I would choose? I would go for the straight chain here, because if I go for the straight chain, I can see a lot of branches here, maximum number of branches, right? So I will choose the one that has more number of branches. So this is a rule. This is a small rule that you have to consider. If two or more longest carbon-carbon chain are there. So here there are two long carbon chains, right? And you have to select which one. So in this case, you would select the one with more branches. So if I select the green numbering, there is only one branch, right? But if you select the red one, there are two branches. So I would prefer the red one, not the green one. I hope I'm clear here. Okay. So let's write down the name, okay, over here. So I will fill in the carbon atom. So I already told you how to fill in the carbon atom. Here, one valency is satisfied, so I need 3 more. Here, 2 valencies are satisfied, so I need 2. Here, 3 valencies are satisfied, I need 1 more. So here 3 valencies are satisfied, I need 1 more. Here, only 1 valency is satisfied, I need 3 more. In this carbon atom, 1 valency is satisfied, I need 3 more. So here, 2 are satisfied, I need 2 more. Here, 1 is satisfied, so I need 3 more. Let's write the name. Okay. Over here. Now coming to rule number 3. So first is always selecting the long chain carbon atom. And if you have selected the long chain carbon atom, if you get 2 long chain carbon atoms, select the one which has more branches. Okay, coming to rule number 3. Okay, now suppose I have okay. So this is the long carbon atom chain. So I'm just filling in the hydrogens first. So here, 1 valency is satisfied, I need 3. Here, 2 valencies are satisfied, I need 2 more. Here, 2 valencies are satisfied, so I need 2 more. Here, 2 valencies are satisfied, so I need 2 more. Here, 2 valencies are satisfied, I need 2 more. Here, 1 valency is satisfied, I need 3 more. Here also 1 valency is satisfied, so I need 3 more. Right. Now, suppose you have to number it. Okay. You number it from this side. 1, 2, 3, 4, 5, 6. Yes. You can also number it from this side. 1, 2, 3, 4, 5, 6. Both the ways you can number. But in both the ways, you're getting 6. And both of them, you're getting long chain only. But which one would you prefer? the red one or the green one, which numbering you would prefer. In such cases, number the chain from the side in which the branches get the lowest number. So if you look at the red numbering, the branching is, this is the branching, right? So branching is getting number 4. But if you see the green numbering, you will see it's getting number 3. So we would ignore this numbering and we would go for this green numbering, because here methyl is getting, the substituent is getting number 3. Okay, so how would you name it now? How would you name it? So first we mention the name of the substituent and the position. So 3-methyl, substituent is methyl, and the main chain is having 6 carbon atoms. So hex because there is no double or triple bond. So single bond. Okay, so why we did not prefer this numbering? 1, 2, 3, 4, 5, 6. If we prefer this numbering, the naming will be 4-methyl hexane. So the prefix or the substituent methyl is getting 4th position. So 3rd position is preferred compared to the 4th one. So this numbering is wrong. This numbering is correct. Okay, in which the substituent is getting the lowest number. So we will not use this numbering. We will use 3-methyl hexane. Okay, this is the 3rd rule, in which the substituent is getting, number it in such a way that or number it in from that side in which the substituent is getting lowest number. Coming to the next one. Next rule, rule number 4. Now, suppose I have a carbon chain. Okay, I have branching here, I have branching here. Okay, now I fill in with carbon atoms. So here 3 plus 1, 4. Here 3 of them are satisfied. So here there's a carbon atom. So this is 3 plus 1, 3 plus 1, 4, CH2, 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 this is CH3, CH3. Okay, now I would number it 1, 2, 3, 4, 5, 6. This is the lowest. This is the numbering, and I'm getting 6 carbon atoms. Then again, if I can also number it from here, 1, 2, 3, choose another color. 1, 2, 3, 4, 5, 6. So in either way, I'm getting the longest chain. Okay. Here, if you see, there are branching. If you see the numbering over here, there is branching at 5. There's branching at 2. right? So in the first one, in the numbering where I've done it on top, here, if you see, there is branching at 2. In 2, how many branches are there? 2 branches are there. 2 methyl groups are there. So I write 2, 2. And at the 5th position also there is branching. Right. Now, if you see the next branching over here, you can see that there is branching at number 2. There's branching at 5. And at 5, how many branches are there? 2 of them. Now, in both the ways, it's a long chain carbon atom. Okay. But the branches are getting different numbers. In such a case, what would you do? In such a case, you would use a rule called lowest sum rule. You would add the position. For example, if you see the first numbering, what is the sum of the position? 9. If you see the second numbering, what is the sum of the position? It is 12. So lowest sum rule means you will prefer the one where the sum of the positions is lesser. So you would use this numbering where the branches are getting lowest position, or some of the branches are getting the lowest number. Okay, so which one would you prefer? You would prefer this one. Okay, so I'm removing this. We will not use this. Okay, so if you choose this numbering, what will be your name? At the second position, 2 substituents are there. So 2,2-dimethyl. Sorry, 2,2. There's also methyl in the 5th position. 2,2,5-trimethyl. 3 methyl groups are there, and hexa group, hexene. Okay, so this is how you select if you have branches and if you have long chain. If you're getting long chain, either way, you will determine on the basis of what lowest sum rule. Okay. Similarly, if I give another example, don't worry about the picture here. This is called as bond line notation. Bond line notation, according to which all these are carbon atoms. Okay. All these top of the mountain and these tips are all carbon atom. Okay, all these are carbon atoms. So this is all carbon atoms. This is carbon atoms. Okay, so this is carbon, this is carbon, this is carbon, carbon, carbon. All these are the carbon. And this is what motion? Bond-aligned motion. Okay. So let's number it. So 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? I can also do the numbering. I'll redraw it again and then draw it otherwise. So 1, 2, so I can also number it from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Both of them are giving me long chain. Okay. So here, if you add up the position in the first one, what do you get? At the second position, there is one methyl group. So this branching means it is the substituent group. And at the seventh position, you can see 2 are there. 7 plus 7. So it is giving you 16. Now, if you go to the next one, I have just numbered it in the reverse order. Here in the third position, you are getting one branching and 2 branching. In fact, here this is one branching, this is another branching, right? So 3. And at the 8th position, you are getting 1. So if you add up, what is the sum you're getting? 14. So which one would you prefer? Definitely you prefer this one. 2 long chains. One is position 2 plus 7 plus 7. Next is position 3 plus 3 plus 8. Right, these are the 2 positions. And you chose to use this positions because this is giving you a lower sum than the previous one, right? But there is a small rule that you must take care, which tells you rule number 5, which is called as first point of difference. Okay, that means in simple words, where you first find the substituent or branching. Don't get confused regarding this. So here, if you compare, that's why I've written it, I'll write it at the side here, 2 plus 7 plus 7. This is according to the first chain. Okay. Second chain is 3 plus 3 plus 8. Okay. From here, if you see the first point of difference, you're giving the substituent the lowest number 2. Okay. Even though the other 2 branches are getting bigger numbers, but the first point of difference, this is, you compare the first point of difference. That is very important. Okay. If the substituents are equidistant, then you use the sum rule. Otherwise, this is a very important rule. This dominates over the sum rule. The first point of difference. So you will not use this naming. Instead, you will use this because the first point of difference, position 2 is getting the substituent, but over here, position 3 is getting the substituent, which will not be accepted. Position 2 is lesser than 3. That is why the first point always, if you have a confusion, you write like this and check the first point of difference. Okay, so if the first one is getting lowest number, you prefer this chain. I hope I am clear. Okay, so this is the 5th rule, first point of difference. Okay, and most of the 99%, it will be matching with the sum rule. Okay, so I will explain this with one more example. Okay, first point of difference. Okay, first point of difference. So, for example, if I have okay, So this is one carbon atom. This is another carbon, another carbon, another carbon, another carbon, another carbon, another carbon. So all these mounds are carbon and all these crust centroids are all carbons. Okay. Now, over here, let's number it now. Suppose I number it from here. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Or you can also number it from here. So 1, 2, so 1, 2, 3, 4, 5, 6, 7, and 8. So let's write down the position. Both are long chain, yes. So sorry, I'm sorry. I have to draw another branching over here. Branching over here. So this is carbon atom, okay? So this is the 6th position. Okay. Now let's write down the position from the first numbering. We have one branching at the 3rd position. We have one branching at the 5th position. Right? Now, in the second one, we have one branching at the 6th position, one branching at the 4th position. Okay, so which one you will choose? You will check the first point of difference. The first point of difference is at the 3rd position, you are getting the first substituent, but in the second numbering, you're getting the first substituent at the 6th position. So this will be wrong. You will go with the first substituent at the 3rd position. So what will you name? So you will not use this numbering. You will use this. At the 3rd position, there is a methyl group. And at the 5th position, you can see there are 2 carbon atoms, right? So this will be CH2 and this is CH3. Okay, so that means CH2, CH3 is nothing but ethyl group. Okay, at the 5th position, there is ethyl group. Okay, now when you have a substituent, there are 2 different substituents. Okay, you will write it in the alphabetical order like M and E. Which one comes first in the alphabetical order? Ethyl group. So the position, irrespective of the position, we will write 5 ethyl, 3 methyl. There are 8 carbon atoms, so octane. Okay. And here, di, tri, etc. does not come in alphabetical, is not considered in alphabetical, is not considered in alphabetical order. I'll give an example. I hope the first point rule is clear to you. So here the alphabetical order we consider because there are two different subsequent. Okay. And this is ethyl group. Okay, there's a carbon atom, two valency is satisfied, it needs two more. Here one valency is satisfied, it needs three more. That's how it is CH2, CH3. Okay, so let's do one more question. In this rule, okay. So don't worry about it. We will give a lot of practice and it will be clear. Okay. So bond line structure again. Okay. So this is one carbon. This is another carbon, 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 carbon. This is carbon, again CH2, CH3. This is carbon, this is carbon. Okay, let's number it now. 1, 2, 3, 4, 5, 6, 7. So 5, 6, 7 also, you can number it that way. Using okay, if I'm using if I'm numbering this way, okay. So what are the positions of the substituents? At the third position, there are two methyl groups, and at the fifth position, there is one ethyl group. Okay, so let's number it in another way. Let's check if it's possible. 1, 2, 3, 4, 5, 6, 7. Okay, so if we number it this way, at the third position, we are getting one substituent. At the fifth position, we are getting two methyl group. Now, over here, if you see, the first point of difference, both are the same. So we move on to the next one. Among 3 and 5, which one is getting a lower position? Where the substituent is getting lower position? Of course, 3. So definitely we will not use this numbering. We will use this numbering 3, 3, 5. So I hope the first point of difference is clear to you. Okay. So now coming to the naming. At the third position, there are two methyl groups. So we have 3,3-dimethyl. Okay. And at the fifth position, there is ethyl group. This is CH2. This is CH3. CH2, CH3 is ethyl group. Okay. So now over here, which one to name first? Here there is a di. We will not consider the di, tri, etc. in alphabetical order. We will start with M. Okay, so which one will be given, will be first? 5-ethyl, 3,3-dimethyl, heptane. Okay, I hope I am clear here. Okay. So the first point of difference is a very important rule. Okay, it is very, very important. Coming to one more question. I have carbon, 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 carbon. Okay. So here there is a chloro group. And I have here there's a bromo group. Okay. So I'll fill in the carbons. There are 2 valencies satisfied, 2 more is required. 2 is satisfied, 2 more required. 2 valencies satisfied, 2 more required. Here 1 valency, 3 valencies satisfied, 1 more needed. Here 1 valency satisfied, 3 more needed. Okay. Now here you will start to number 1, 2, 3, 4, 5. Right? Here also, first point of difference, you are getting chlorine at the first position. So definitely the numbering should be from here, because if you number from here, you're getting the, so this is 1, 4, right? But if you number from here, 3, 4, 5, this is 2, first point of difference is, you can see, you're getting in the first numbering, you're getting chlorine at the first position. So definitely you will prefer that. Okay. So this numbering we will not prefer. Now while naming, what would you do? At the first position, there is chloro. At the fourth position, there is bromo. So here, you will look at the alphabetical order, irrespective of the position. So you will name it like this: 4 bromo, 1 chloro, pentane, because there's no single, double or triple bond. Okay. Similarly, if I have 1, 2, 3, 4. Okay, this is chlorine here, this is bromine here, and I fill in the hydrogen. 2 are satisfied, 2 more required. 2 valency satisfied, 2 more needed. 2 valency satisfied, 2 more needed. 2 valency satisfied, 2 more needed. Okay, now here, one way of numbering is 1, 2, 3, 4. So 1 and 4, the substituent at the first position and fourth position. Now, another way of numbering is 1, 2, 3, 4. Here also 1 and 4. Both are equidistant, both first point of difference is same in both the cases. In this case, you will go with the alphabetical order. Now here, in this case, because the first point of difference is same in both the ways of numbering, we will choose what? We will choose the alphabetical order. So in this case, 1 bromo, 4 chloro, butane. Why? Because the first point of difference is same in both the cases. We are getting the same positions. Okay. From both the side, it is the same. Right? I hope it is clear. So according to this, we have our 7th rule, which says if there is a tie, here there's a tie happening, right? Tie on the first point of difference. The first point of difference is the same. All the numbers are matching, same. First point of difference, then check the alphabetical order. And what is the condition? There's a tie on the first point of difference, as you can see here. The first point of difference is the same. Okay. So let's practice some questions now, right? So these are the rules, students, which you will be following. Okay, so today we learned about alkanes today. Okay, so you will practice some questions now. Okay, questions. Suppose I have a question like this, okay, and you know that this is carbon, 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 carbon, carbon. Okay, so if I write it like a straight chain, or if I write it in the chain structure, it will be carbon, 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 carbon. So there will be 4 carbons, 1, 2, 3, 4. And this is carbon, this is another carbon, this is another carbon, this is another carbon. So I have carbon, 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 carbon. So here one valency is satisfied, so it needs 3 more. Here all the 4 valencies are satisfied, 1, 2, 3, and 4. Here also 1, 2, 3, and 4. Here one valency is satisfied, I need 3 more. Here one valency is satisfied, so it needs 3 more. One valency is satisfied, 3 more. Here one valency is satisfied, 3 more. One valency is satisfied, 3 more. So you can do it directly also, okay? Or you can draw like this and prove it. It's up to you. So if I number it, so 1, 2, 3, 4. If you number it the other way, so here the positions are 2 and 3. If I number it the other way, 1, 2, 3, 4. So here also 2 and 3. So first point of difference is the same. So you can number it either way. So here in this case, what would be the name? At the second position, there are 2 methyl. At the third position, there are 2 methyl groups. Second position, 2 methyl group. Third position, 2 methyl group. And how many methyls are there? 4 in total. So tetra methyl butane. Okay. Next one is this is one carbon, another carbon, another carbon, another carbon. So if you draw it like a structure, this is carbon, 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 and carbon. So filling in the hydrogen, one valency is satisfied, 3 more. One valency is satisfied, 3 more. 3 valencies are satisfied, 1 more. 3 valencies are satisfied, 1 more. Here 1 valency is satisfied, 2 more. Sorry, 3 more. Here also 3 more because 1 valency is satisfied. Now, if you number it, 1, 2, 3, 4. You can number it 1, 2, 3, 4 also. Okay, either way, it is giving you the longest chain only. Okay, so at the second position, there is so this is the first carbon, second carbon, third carbon, fourth carbon. So second position and the third position, there are methyl group each. So dimethyl, this is one methyl and this is one methyl. So dimethyl butane. 4 carbons, so butane. Okay. The next one. Okay, so this is one carbon, another carbon, 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 carbon. So one valency satisfied, three more needed, two valency satisfied, two more needed, three valency satisfied, one more needed, two valency satisfied, two more needed, one valency satisfied, three more needed, two valency satisfied, two more needed, two valency satisfied, two more needed, one valency satisfied, three more needed. Okay, now over here, the numbering 1, 2, 3, 4, 5, and 6. So if we do 1, 2, 3, 4, 5 only, you will get. So I think this is the longest. So 1, 2, 3, 4, 5, and 6. So at the third position, this is the ethyl group I was referring to. So at the third position, there is ethyl, 6 carbon atoms, so hexane. Okay. Next question. Write it in terms of carbon. This is how the skeleton looks like. And here, if I number it, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right? So over here, at the 6th position, there is methyl group. And at the 5th position, there is ethyl group. Okay. If you are numbering it, suppose from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You're getting the long chain. Let's check out 6th position ethyl group and 5th position methyl group. So both are, the first point of difference for both of them is the same. At this case, at this situation also, you will use the alphabetical order because the first point of difference is the same. Okay, so you're getting the same numbers, or you're getting the substituent at the same numbers. Okay, here you will go with the alphabetical order where ethyl is getting position 5. Okay, rather than position 6, because here you will consider the alphabetical order. So you will use this numbering. I hope you understood because the first point of difference is the same. So here you will name it like this. 5 ethyl, 6 methyl, decene. When we number it from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we get what? 6 ethyl, 5 methyl, decene. Okay, so here ethyl is getting bigger position. Here we are preferring the alphabetical order because the first point of difference is the same. Okay, so here we will use this because the first, according to the numbering, here we are getting 6 and 5, right? Here also we are getting what? In both the ways of numbering, we are getting 5, 6. The positions of the substituents are at the same position. The first point of difference is the same. So at this time, we will use what the alphabetical order is preferred. Okay. So students, that's all for today. We will have more videos on the naming of different substituents. That's all for today. Thank you. Have a great day.